This is a Revit 2011 tutorial on doing roof crickets, and I know in the past what a lot of us have done have just kind of blown by it and just drawn a graphical representation of the cricket and let it go. And so most of us just go in here and we say, okay, there's a midpoint. We're going to have a roof drain or scupper there, and let's just draw some cricket down here at some angle. And we never really, gave a thought pretty much as to, what that actually induced as a valley slope across this this interface between the roof and the cricket. And we know that, if we have a surface that's running in this direction, that this relative to this roof, it has no slope, and then if it's running up the slope, that's going to have whatever the roof slope is. And by code, the minimum is 3/8 inch per foot required slope on the roof. I like to use 1/2 inch just to get a little more velocity of the water, to get it off the roof and prevent any kind of ponding, which actually will start to deteriorate the roof after a while. Maybe not as big a deal in Arizona where we live, because things dry up so fast, but in a wetter climate, you want to have a pretty substantial roof slope. Make sure that water gets off there. So you would think, if we come off here at a 45 degree, that this would be a 1/4 inch per foot slope, intuitively, but that's not the case. So if I was going to construct a roof cricket here, at first I need to put in a roof. So why don't we go ahead and do that, just so you know how to do a roof. So we'll do a roof by extrusion, and I'll pick a plane here. Pick this plane. I'll go to section 5, and we'll just set that to level 1. So since I like to use 1/2 inch, I'm just going to come in here and go across 12. Up 6. And back down, close the triangle. Get rid of those guys. Shift, drag, shoot that out there. And then we just want to check the type. So 15-30 seconds plywood is fine if you're going to use some sort of structured assembly, whatever it's going to be. So we'll just use the plywood. Say OK. Finish that off. Okay, so it gives us a little roof in there. And we need to go to level 2 here. It should be there. Actually, just go look at this in 3D. Alright, where's my roof? Alright, so I just drag it out and get a roof in there. And then we're going to construct a quick cricket in here. We're going to do another roof. We're going to do this one by footprint. Select a boundary line. And you'll notice that these have kind of predefined slopes to them. So we want to make sure that we turn all those off. And then we're going to use a slope arrow. And we're going to use that. We're going to use the midpoint. And then we'll go off in some direction, 90 degrees to the face here. Obviously it's a level 2, so let's just move it up. Alright, and you can see that this is just at some kind of weird angle here. And obviously it doesn't sit flush like we want it to. Alright, so what I did was I went through and I kind of looked at you know, what angle does this really need to be, you know, to interface with the roof appropriately, and then what slope do we want to set this cricket at. So I looked initially at just say a 45-degree angle on the cricket, all right, and determined by looking at this section actually right in the valley here that it was giving us a 11/32 inch per foot valley slope, all right, and that's using a 1/2 inch per foot roof slope. So the interface, that's, you know, that's what we're getting with that particular interface. And determine that if you want to get a true 3/8 inch per foot code minimum slope in the valley, that this angle actually needs to be 46 degrees for a 1/2 inch per foot sloped roof. So that's the interface that you need. All right. Then the other question that comes up, and let's just look at this in 3D real quick. So let's look at that condition. So what you'll notice here is that, so widen this out a little bit. You notice that we flush okay down here, but we don't flush down at the other end. All right. And we need to look and see, you know, what slope we're going to make that, and how long that slope arrow needs to be. So let's look real quick at this section here. So looking at the different slope arrow lengths, initially I started out with 12, and that was giving me a 10-inch rise. And then I said, okay, well, you know, let's double it to 24. All right, so we're getting a 5-inch rise, so it's halving as you go down. And took it on down to you know, like 96-foot length on the slope arrow. And let's see, I don't know if you can see that. Just edit the footprint, and you can see the slope arrow. In this case right now, this one's set to 240. I'll show you why. So what I determined was that if you just take the math, you run the math, you take 96 feet times 1.25, which is the rise that you're wind up with in that particular setting of 96 foot, that equals 120 feet. So if we kind of run the math backwards and we say, okay, 120 foot divided by 1.25, that's 96 feet. So if we want a 1/2 inch per foot slope, we'll take 120 divided by 0.5 of an inch, and we'll determine that the slope arrow needs to be 240 feet long. So that's your equation there. If you're trying to determine the slope on a roof, just take 120 divided by the slope you want, and you'll know how long you need the slope arrow to be. All right, now to deal with the that issue of the cricket kind of sticking up here, we need to actually rotate that that slope arrow a little bit. So this one actually is has been corrected. So you can see that this one is flushing nicely at the low end and the top end, and we'll just look and see what that that rotation is. And here you can see it's it's 45 degrees from the high end, and it's 135 from the low end, and that will let that cricket sit in there flush. Again, that's for a 1/2 inch per foot sloped roof. All right, and then once you have the your first cricket established, it's pretty easy to just mirror across, and now you know that your crickets are constructed properly. You can put control dimensions on there to make sure that they actually build them in the field properly, and that you're maintaining that code minimum 3/8 inch per foot slope throughout the roof, even in your valley conditions. And that's pretty much how you deal with crickets in Revit.